Good evening, everyone just joining. Welcome to tonight's live. Good evening, good evening, good evening. You all are welcome. If you've not shared the live, maybe you want to do that so that others can be um, invited as well. And please let's like up the live already. Let's do that double tap. Welcome, welcome, welcome. All right, so we're going to start with approximation. We're going to start with approximation. Approximation, yeah. Approximation basically is something or is a thing that is similar to another one, but not exactly the same. Hello, Abdulgani, welcome. Approximation is a thing that is similar to something else, but not exactly that same thing. All right. In maths, approximation is a value or is a number that is similar to another number, but it's not exactly that number. For example, 2.1 is similar to 2. Like if you go to a supermarket, for example, ShopRite, you buy a bottle of Coke, maybe they tell you it's 149 naira, 99 kobo, or whatever. Now you approximate this amount, at the end of the day, you pay 150. So we do approximation all the time. Approximation is a value, is a thing that is similar to another one, but not exactly that one. That's what approximation is. So now, how do we work? How do we do approximation of numbers? How do we do approximation of numbers? Good evening, Zainab Usman. Good evening to you. How do we perform approximation of numbers? How do we perform approximation of numbers? There are basically 3 steps to approximating numbers. 3 steps, all right? But before I will talk about that, let me talk about rounding up numbers. We approximate numbers by rounding off. By rounding them, all right? Rounding them off. It's either we round up or we round down. So we approximate numbers by either rounding up or rounding down. What does this mean? To round up and to round down. What does it mean to round up a number and to round down a number? Hello, Caroline. Good evening to you. So assuming I have 1, 2, 3, and 4, I would want to think that there are no numbers between 1 and 2. That immediately after 1, you have 2. But no. This is where decimals come in, alright? So decimals are numbers that are less than 1. Let me explain this with, say a bottle of Coke. You buy a bottle of Coke, alright? This is one bottle of Coke. So you open it, you drink a part of it. And now it's now less than what you bought. You bought 1 bottle of Coke. Now what you are having, is it still 1 bottle of Coke? If it's not up to 1 bottle of Coke, is it 0? It's not 0 because 0 means nothing. 0 means nothing. So what then is this one? This one therefore is between 0 and 1. Alright, it's a decimal, it's a fraction. So that's where decimals come in, 0 point something. And in decimals we count 0.1, 0.1, 0.2, 0.3, 4, 5, 6, 7, 8, 9. Alright, before you get 1. Alright, even before this place, and so you still have another place. So just like we have places in the old numbers, maybe I should talk about the place value also. Just like we have places in old numbers, your units, your tens, your hundred, your thousand, we also have places in the decimals. So we have the tenths, you have the hundreds, you have the thousands, the 10,000s, 100,000s, and so on, millions, and so on and so forth. Good. So, back to rounding up numbers. So back to rounding up numbers. Now, how do we round up numbers? If you have 1 and 2, let's have decimal place. Let's write decimal places with in the nearest tenth. So we're going to have 1.1, 1.2, or let me start with 1.0. 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9, 1.9, and 2.0. So this is telling you that between 1 and 2 you have all of this. Even between this, there are other places. So if you divide this place now between 10, into 10 places rather, you're going to have 1.01, 1.02, 1.03, 1.04, 1.05, 1.06, 0.9 before you have 1.1, all right? 1.11 and so on and so forth. It keeps going that way. So, between 1 and 2, you have these divisions, all right? Now, 1.9 is closer to 2.0. 1.1 is closer to 1.0. 1.8 is closer to 2.0. 1.2 is closer to 1.0 than to 2.0. 1.7 is closer to 2.0 than to 1.0. 1.3 is closer. Let me write it out on a straight line. So on a straight line, we have 1.1, we have 1.2, we have 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9. Now, at the two ends, we have 1 here and we have 2 here. So between 1 and 2, we have all of this. So 1.1 is closer, 1.9 is closer to the 2, 1.2 is closer to 1, 1.8 is closer to 2, 1.3 is closer to 1, 1.7 is closer to 2, 1.4 is closer to 1, 1.6 is close. So this is like the middle point. This is the middle point. So when we talk about rounding up and rounding down, rounding up a number simply means if the number you want to round up falls in this zone, you will approximate it to 2. Alright? So if you have like 1.6, you push it to 2, alright? To the nearest whole, which is 2. But if it is not up to 1.5, you approximate it down. So this is rounding down to 1, and this is rounding up to 2. Rounding up and rounding down and rounding up. So that's what rounding up numbers mean. That's what it means to round up numbers. Now, back to approximation. So what are the steps involved in approximating a number? What are the steps? Hello, Becky, good evening. What are the steps involved in approximating a number? 3 basic steps. Step 1, locate the place you are told to approximate to. Because when you are told to approximate, you always be told to approximate to a given place. Either you will be told to approximate to the unit place, to the tenth place, to the 100th place. It could be to the 10th, it could be to the 100th, whatever place, alright? So, locate the place, the specified place or the given place. Two, the second thing you want to do after locating the given place. Let me give an example. So as I'm making mention of each one, I'm explaining with an example. So you have 1.529 and you are told to approximate this number 1.529. You're told to approximate this number to 2 decimal places. 2 decimal places. 2 decimal places simply means 2 numbers or 2 places after the decimal point. What part does 1.5? Yeah, 1.5 is added to the higher part. Alright, so from 5, 6, 7, 8, 9 upward. So we round up. But if it's not up to 5, so 4, 3, 2, 1, 0. Rounded down. So we are told to approximate this number now to 2 decimal places. Approximate this number to 2 decimal. By the way, approximation, you have it in the primary, you have it in the junior secondary, senior secondary, you have it everywhere. Alright, so it's important for everybody. Approximate this number to 2 decimal places. That's the question. 2 decimal places. So the first thing is to locate the given place. So I need to locate the given place. 2 decimal. Where's the 2 decimal? There's 2 numbers after the decimal point. So 1, this is decimal point. So 1 and 2, this is the place. The next thing you want to do is to check the number at the right. That is the number next to it. Alright? Hello, Jonah. Welcome. Good evening. Yeah, long time. Welcome. So check the next number to the right. The number to the right. Alright? The next number. Check the number to the right. That's this direction. Alright? This direction. The right. Then what's the third thing? Okay, in this case now, check the number to the right. So this is our place. With place we were told to approximate to. The number to the right is 9. Alright? So this is the number next to it, which is 9. Now, what are we going to do with this number? That brings us to the third step. The third step is for us to round up or down. So we're going to round up or we're going to round down. So with 9 here, the question you want to ask yourself now is, am I rounding up or am I rounding down? Again, locate the given place. What's the question? Approximate 1.529 to 2 decimal places. What is it? Where are the 2 decimal places? Here 1 and here 2. Alright, so what's the next number, which is step 2? Check the next number, that's to the right, which is 9. Now what are we going to do with this? Number 3, round up or down. So what are we going to do? Hello AMT, welcome, good evening to you. Are we rounding up? Okay, you say up, good. I said again, when you have below from 5 upwards, 5, 6, 7, 8, 9, we round up. But when you have 4, 3, 2, 1, 0, when you have less than 5, you round down. When you have 5 and above, you round up. So we are having 9 here. In that case, what are we doing? We are rounding up. What does it mean to round up? It means you're going to add 1. Like when you have 1.7, so you're adding 1 because you're rounding up to 2, right? So you're going to be adding 1 here. That's what it means to round up. You add 1 to that place. What if this were to be 4? What if it were to be 4? Remember, if it is less than 5, if it's 4, 3, 2, 1, 0, you're rounding down. So what does it mean to round down? It means you're not adding anything, all right? You're not adding anything. You're just dropping it, all right? Just like when you have 1.3, it is closer to just 1, all right? So you are dropping off this. You're not adding anything. That's what it is to round down. So you go to the place before it. So you have 1.524 now. In this case, the next number is 4. So we are rounding down, which means we are not adding anything here. So we're just going to wipe this off. And we have only, according to the question, 2 decimal places. In other words, only 2 numbers after the decimal point is what we are asked to give. And what are the 2 numbers in this case? 5 and 2. But the first case, it was 9 that we had here. So you have 9, which means you are going to round up, and that this becomes plus 1. And then you have plus 1, and then you have 3. And so what's your answer? 1.53. When you have this, 1.529 to 2 decimal places becomes 1.53, which means you now have only 2 numbers after the decimal point. Thank you, MT. Thank you. Thank you. And by the way, everyone, maybe we should follow AMT too, so he does good. He's also into maths lectures and maths videos like that. So I think he does upload. So please let's follow him also. Let's do well to also follow him up. All right, thank you. So let's continue. The first step is what? Locate the given place. The second step is what? Check the number to the right. Okay? And the third one is what? Round up or you round down. Made a video on assignments. Oh, good. Okay, nice one, AMT. Nice one, I'll check it. All right, let's go and take some examples. All right, let's take some examples. So an approximation. Now let's see some examples. Okay. Before we take some examples, can we do quadratic, please? Not today, please. Good evening. Hello, Faith. Welcome. So before I give you an example, let me quickly explain this also. So you might be told to approximate either to a particular place, for example, to the nearest tens, or to the nearest 1,000, or to the nearest. I want to believe that we already know our place values, but let me still mention that. So if you have a number like 1254.321, the lowest place, all right, for all numbers, the numbers on this side are the whole numbers. Numbers on this side are the decimal numbers. So the numbers before the decimal point are the whole numbers. Numbers after the decimal point are the decimal numbers, all right? So the smallest place or the last place in the whole number, the least place, is the unit place, and then we have the tens place, and then we have the hundred place, the thousand, the tens of thousand, the hundred of thousand, the million, tens of million, hundreds of million. Hello, Timmy. The billion, tens of billion, hundreds of billion, trillion, tens of trillion, hundreds of trillion, quadrillion, quintillion, sextillion, septillion, all of that. By the way, I hope we know that numbers have no end, all numbers. Okay, so how about the decimal place? We have the tenth, that's T-E-N-T-H. So this is 10, that's T-E-N, whereas for the decimal we have 10, all right, with the T-H. All of the places here we have the T-H, T-H. So we have 100. So what we have here is like we're having the same thing on this side with the TH, but we don't have anything units on this side. So we have the 10th, we have the 100th, we have the thousandth, so Thousandth. So in case you are told to approximate to the nearest 10th, this is the place, all right? So in case you are told to approximate to the nearest 1,000, this is the place. In case you are told to approximate to the nearest 100, this is the place, all right? So you need to know your place values first. Now, what if you are told to approximate to the nearest whole number? What if you are told okay, yeah, it's part of what I'm going to make mention of. So what if you are told to approximate to the nearest whole number? You are told to approximate to the nearest whole number. What does that mean? The nearest whole number simply means the last whole number. That's the whole number before the decimal point. So this is our decimal point. The nearest whole number is what? This place. The last whole number. That's the unit place. So whenever you see approximate to the nearest whole number, yes, Walt Godwin. So whenever you see approximate to the nearest whole number, we're being asked to approximate to the unit place. That's the last whole number before decimal point, all right? In this case, it is 4. All right? Good. Then the next thing we want to talk about is the significant figures. Significant figures. So you'll be told, you see questions that will say approximate to the nearest whole number. You see questions that will say approximate to the nearest 1,000. You see questions that will say approximate to the nearest tenths. You see questions that will say approximate to decimal places. I've made mention of that already. So like 1 decimal place means 1 number after the decimal point. 2 decimal places means 2 decimal. Hello, Papa, it's been a long time. Welcome. Good evening to you. 2 decimal places means 2 numbers after the decimal point, 2 places after the decimal point. 3 decimal places means 3 places after the decimal point, all right? But now, significant figures. What exactly are significant figures? So significant figures are the numbers 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. What does the word significant mean? The word significant means valuable, all right? Tangible, all right? Having value, significant, okay? So 0 is not a significant figure. 0 is not counted as being significant. That's why if you have 0.2 here, for example, this 0 is not significant, so it is as good as just 2. But there are cases where 0 can become significant. For example, if you have 205, 0 in this case becomes significant. So whenever you have 0, in between a significant and another significant, the 0 in the middle becomes significant. Alright? So this is not the same thing as 25. You're not going to say, okay, 0 is insignificant, it becomes 25. No. Alright? It is significant in this case. So now let's take some examples. So examples. Example number 1. The question says approximate 65009. Approximate 65009.269 to 1. To 1 decimal place and 2 to 1 significant figure. Okay. To 1 dp and then to 1 sf. To 1 dp and to 1 sf. Approximate 65009.269 to 1 decimal place. When you see dp, that's 1 decimal place. When you see sf, that's 1 significant figure. So approximate to 1 decimal place and approximate also to 1 significant figures. So let's solve that. Solution. So for the first one, we're told to approximate to 1 decimal place. Remember your steps. The first one is what? Locate the place. The second is what? Check the number next to the right, right? The third one is what? Round up or round down. You're rounding up or rounding down based on the number after, all right? The number after will tell you if you are to round up or if you are to round down. So let's look at what we have. We have 65009.269. Want to approximate to 1 decimal place. Locate the place. That's where is 1 decimal place here. 1 decimal place, remember, it means 1 place after decimal point. So where's our decimal point? This is the decimal point. So where's the place? That's the 2. Good, the 2. The 2 is the 1. So this place here, 2 is in the 1 decimal place. This place right here, where 2 is the 1 decimal place. So what do we do next? Step 2, look at the next number. What's the next number? 6. So now, the third step now, you're going to round up or round down. 6 will tell you if you have to round up. The number here will tell you if you have to round up or round down. So what are we going to do? Let me ask us. Are we going to round up or are we going to round down? Are we going to round up or are we going to round down? Up or down? Are we going to round up or down? What's God may say round up, okay? Are we going to round up or are we going to round down? Abdulganiyu says up, okay? Lecture 5 says round up. Bold and Sickle says up. Andrew says round up. Seprin says up. Emmanuel says up. Biliano says up. Up. Round up. Up. Good. So we have. Let me write it this way. So we have 1 here. So we have 1 here. We have 2 here. Okay, 1. So 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, then 2. So this is 2 and this is 1. So all these numbers here, we are rounding down to 1. Then all these numbers here round up. So how about this one? Added to this. So from here, we round up. But from here, we round down. So 5 upwards, we round up. 4 downwards, we round down. Yeah. So we're going to round down. 6. What does that mean? It means we're not adding anything here. So we're just going to take your 6 and your 9 off. Alright, so what is it going to give us? By the way, the symbol for approximation is this. Just like waves. Alright, that's the symbol for approximation. Approximately equal to, different from the normal, equal to, approximately equal to. So this now is approximately equal to 65009.2. And that's it to 1 decimal, to what? 1 decimal place. So this is how you approximate numbers. Approximate up 269 to 3. Good, it becomes 3. No, not to 3. Approximate up, 6. So we approximate up, it becomes 3. Thank you. So it becomes 3. Good. So we approximate up, it becomes 3. But if we are rounding down, if this is not up to 5, we are going to approximate. We are going to round down, and this one will remain as 2, and these ones will be dropped off. In this case now, we add 1 here, becomes 3, still these ones are dropped off. Alright, it's either we add or we do not add. In both cases, the other numbers will be dropped off. Yes, Larex, you're correct. You're correct. Alright, so let's go for another example. Okay, we're not done. We still have another one significant figure. So if we are going to approximate this number now to one significant figure, you want to ask yourself, amongst these numbers, where do we have the first non-zero or the first significant figure? Of course, we have a significant figure here. And so that's 1, that's 2, right? So, but we need just one significant figure. And this is it, 6 here. Okay, that would be number 2. Let me solve it here. So 65009.269. That's our number, right? So to one significant figure, this is the place. The same steps you're going to take, whether it is to so decimal places, whether it is to significant figures, great Emmanuel Debbie, whether it is to a particular place, whatever, the same steps. Locate the place, check the next number to the right, round up or round down. So one significant figure, this is the first significant figure. What's the next thing? Check the next number. What's the number? 5. Alright, so what are we doing? Round up. Well, God may say round up. Good. So round up. We're going to round up because it's 5. Remember? So from 5 up, we round up. From 4 down, we're rounding down. So what does it mean to round up? It means we're going to add 1 to this, right? And then it becomes what? 7. So approximately equals to what? 7. So what about these ones? What about this one? What will happen to them? They will all be changed to zeros. So you're going to have 0, 0, 0, 0. And that's for the whole numbers. That's for the whole numbers. We can drop all of this, all right? It becomes point. It becomes 0.000, but this is insignificant, and so we leave it this way. 70,000 to one significant figures. If you give your answer as this, you will still be correct though. But note, when it comes to decimal places, it is clear. For example, one decimal place means they want just one number after the decimal point, all right? So you don't want to add any other zeros. It has to be just one number, like in this case, all right? Thank you, Walter T, for the rose, for the gift. Thank you. Thank you. So it's just one number. If they say 2 decimal places, it's specific, it's clear. Just 2 numbers after the decimal point. Thank you again. Thank you for the gifts, all right? If they say 3 decimal places, just 3 numbers, okay? So if you give your answer this way, you'll be correct. If you give your answer this way, you will still be correct. It's still only one significant figure. Let's go for another example. Okay. Are we writing? So I'm going to thank you. Queen Benny, thank you for the rose. Thank you. Walter T, thank you for the TikToks. Thank you again for the rose, for the gifts. Are we writing this down? If you're writing, please write fast. Okay, Ali, write fast, please. I won't believe that we're done now. I'm going to just give 2 more examples and that will be it so that we can switch over. So example number 2 now. King Derek, thank you. Done, good. So example number 2. The question says, example number 2. By the way, this is an Echo GC question. It says express 0.0154 15849 correct to 3 significant figures. correct to three significant figures. Significant figures. So that's the question. Express 0.015849 correct to three significant figures. And so we have options. Option A says 0.0158. Option B says 0.0159. Option C says 0.0160. And option D says 0.020. That's the question. That's the question. So what will be the correct answer? Which of them is the correct answer? Express 0.015849 correct to three significant figures. Which of them is the correct answer? A, B, C, D. Correct to three significant figures. Timmy says A, Wells Godwin says B, Abdulkadir says C. Okay, Issa Ali says C, Andrew Centric says C. Correct to three significant figures. C, C, B. Really, exam? You don't understand, okay? We're going to answer. Okay. So we have we have this number. We're told to approximate to three significant figures. Solution. So three significant figures. So let me write the solution here. Alright, so what's our number? 0.015849. So the significant figures are the non-zero numbers, alright? The numbers except 0. So 1, 2, 3, 4, 5, 7, 8, 9. All those are the significant figures, alright? 0 is only significant when you have it between a significant and another significant. So we want to check, where does the significant number start from? 0? No, it's not significant. 0, it's not significant. So this is where significant figures start from. So we have 1 here as our first significant figure, 5 as a second significant figure, hello Alima, 8 as a third. We're told to approximate to three significants, alright? So 1, 2, 3, this is the third one, alright? Remember the three steps again. The first one is what? Locate the place. The second one is what? Look at the number, that check the next number to the right. In this case, to the right, we have 4, alright? Then what do we do with it? That number is going to tell us if we are going to round up or we're going to round down. So how do we know when to round up? 5 and above we round up, 4 downwards we round down. So it means we are going to round down. We are not adding anything. So what will be our answer? Our answer now, this will be approximately equal to what? 0.0158. That's it. So option A is correct. Option A is the correct answer. No, not B. Because we rounded down. The next number is 4. So we did not add anything. Alright? If this were to be 5 or 6 or 7 or 8 or 9, we're going to add 1, it becomes 9. But in this case, we are not adding anything. So we have just this. Alright? So it becomes 0.0158. Yes. Let's see another one. Okay, write fast, please, if you are writing. Okay, I'm going to give one that is similar to this also now. You're welcome. Alima, where are you going to? Are we done? Can I wipe this up now? Okay, the next one says, the next question says, approximate, okay, still the same thing. Approximate approximate 0.004706 to three significant figures. So three significant figures. Our options in this case are, option A says 0.004. Option B says 0.005. Option C says to three significant figures. Option C says 0.00471. Option D says 0.00476. Yeah. So, what's the correct answer? A, B, C, D. A, B, C, D. Approximate to three significant figures. This one now. 0.0047. Okay, C, 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 C. Option C, 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 A, C, 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 C. Okay, good. Solution. So our number is 0.004706. So three significant figures. Alright? Significant? Mm-mm. Significant? Mm-mm. Significant? No, no. Four? Yes. So that's our four significant. Alright? So three significant. 1, 2, 3. Is this zero significant? This zero here, is this significant? This, yeah? No? No? Yes? 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 No? Okay. Remember again, I said, whenever you have zero between two significant figures, it becomes significant. Like 0205. This zero becomes significant. Why? It is between two significant numbers, a significant and a significant. Alright, so make this zero become significant. So in this case also, zero is significant. So we count it among the three. So we have 1, 2, 3. So this is where our three significant, this is where our three significant numbers will stop. So what's next thing? Check the next number. And in this case, the next number is 6. So what are we going to do with it? Are we going to round up? Are we going to round down? Exactly, yes. So are we going to round up or are we going to round up? Are we going to round up or are we going to round up? The D5 says up. What Godwin says up, Abdulgani says up, Timmy says round up. Up, Idoki says up, round up, yes for real, up. Okay, everybody says up. Good. From 5 upwards to round up. 4 downwards to round down. So in this case, we are going to round up. Meaning that we're going to add 1 here. So it becomes plus 1. 0 plus 1 is 1. So this is approximately equals to what? 0.00471. And that's the answer. Which of them? This. So C, correct answer. C, correct answer. I hope we're getting it. I hope we're getting it. Yes, good. Okay, let's go for the next one. One more and then we switch. One more and we switch. Okay, this one says number 4 says correct 87.9152 to 2 decimal places. 2 decimal places. And our options: A, we have 88, B, we have 87.9. C, we have 87.91. D, we have 87.92. And E, we have 87.915. 5 options. Correct 89.9152 to 2 decimal places. Option D, well, says D, 87.92. Okay? Please, when will you teach chemistry? No, I don't teach chemistry. D, at least we are not looking for. C, D, A. It's D. Okay, A, D. Calculus. Okay, no, calculus. Are we going to say weeks? Because calculus is we're not teaching calculus just yet. There are other topics we're going to teach before calculus. D, A. D. Okay. Solution. So we have 87.9152 to 2 decimal places. So 2 decimal places again means what? It means 2 numbers after the decimal point. So the decimal point, then you have 1 place. That's what we call 2 decimal places. So decimal point, then we have 1, 2. So 1 here is in the 2 decimal place, the second decimal place rather. So what's the next number after it? 5. Are we rounding up? Are we rounding down? Of course we are rounding up. So it means what? Means we're going to add 1 to 1 and then becomes approximately equal to 87.92. And that's our answer. So the answer is 87.92. So which of them is correct? 87. Yeah, G. That's the answer. Yes, that's the answer. 87.92. Yeah, D is the answer. I hope we're getting this one. Okay, let me use this one now. Approximate this number to the nearest whole number. This same number. So let me give you options. Approximate this same number to the nearest whole number. To the nearest whole number, what will be your answer? 87.9, 89.0, 88.1, 87.1, 88. To the nearest whole number, what's your answer? Correct this number to the nearest whole number. We have these options. So what will be the correct one? 88, 88, 88, 88, 88, A, 87.9, 88, to the nearest whole number, E, 88. Okay, remember again that nearest whole number talks about the last whole number, right? The unit place. So the last whole number, 87.9152. Whenever you see nearest whole number, it is talking about the last whole number. That's the whole number before the decimal point. So this is our place. Then what's the next thing? Check the next number. The next number is 9, right? So what are we doing? We are going to round up and it becomes what? 88. That's the answer. So that's the answer. 88 is the correct answer. Good, yeah. What if this were to be 89? So without option, what would be the correct answer? Approximate this to the nearest whole number. Or even 99.9152. Approximate this to the nearest whole number. Okay? Approximate this to the nearest whole number. 99.9152 to the nearest whole number. Okay, Wealth Godwin says 100. AMT says 100. Elegant says 100. Okay, good. JOPAJ 100. Andrew 100. Okay, Celine 100. Yat for real 100. Janet Harrison 100. Alima says 100. Good. So to the nearest whole number, this is a number 99.9152. So this is the place now. Look at the number after it, right? 9. So we are rounding up. So if you add 1 to this, are we going to say 9010? Of course not. What number do we have after 99? That is 100. So that's what you're going to have. But if this were to be 89, like we were having, if this is to be 89, so if you add 1 here, what happens? It becomes 90. That's the next number. Good. So that's it. Now that brings us to the end of approximation, so we can switch over to English. We want to talk about question tags. Let me quickly give us assignment on this. Oh, I remember we had an assignment the last time. We've not done the correction for that. So I want us to do the correction to the last assignment. Quickly, the corrections. But let me give assignment on this one first. So assignment. Number 1. Question number 1 says, okay, approximate the following to the nearest A, the nearest whole number, B, the nearest tenth, C, the nearest hundredth. So approximate the following number. I'm going to give you 4 numbers now, 3 numbers rather. So the first one, number 1, it's 2.517. Number 2, it's 7.794. 3 is 0.493. Approximate each of these ones, 1 to the nearest whole number, approximate also to the nearest tenth, approximate also. That is, for this one, we are going to approximate 3 times. Whole to the nearest whole number, to the nearest tenth, and to the nearest hundredth. This one also, to the nearest whole number, to the nearest tenth, and to the nearest hundredth. Please don't write when we screenshot. Please don't write when we screenshot. Then this one also, to the nearest whole number, to the nearest tenth, and to the nearest hundredth. So 3 numbers, do the approximation in this way. That's the assignment.